Algebra 1, Lesson 15, using the distributive property to simplify expressions. How many of us, by raise of hands, are familiar with the distributive property? I think we've gone through enough questions by now, that I've said, hey, what is this next step? I've heard enough of you say, hey, we're going to use the distributive property here to multiply everything by the inside of the parentheses. So we should be in pretty good shape. The distributive property can be used to simplify an expression. Since subtraction is the same as adding, the opposite, the distributive property also works with subtraction, not just addition. Here we see some examples, right? If we've got real numbers a, b, and c, a times the sum of b and c is ab plus ac, or a times the difference of b and c is going to be ab minus ac, right? And you see examples shown out over here. Granted, what I don't like about the examples is that what would we naturally do here due to order of operations? We would add the 2 and the 3 first, wouldn't we? Yeah, typically we're going to add the 2 and the 3, or sorry, the 2 and the 1 first, get 3. 5 times 3 is 15, right? So they give you an example there, but really it would be better off if they'd showed me something like 5 times 2x plus 1, something that wouldn't actually add up. Then whenever I distributed, I'd get a simplified expression like 10x plus 5, something like that. It'd be a little closer to, well, I mean, it's algebra, so in any case, we get the same type of situation down below, which we would have gotten the same thing if we had subtracted first, but 5 times 2 is 10, minus 5 times 1, so 10 minus 5 is 5, or 2 minus 1 is 1, and 5 times 1 is 5. So I'd still get 5 either way. Questions, comments, concerns so far? No? Okay. All right, unlike the multiplication, use the multiplication property of -1 to simplify an expression. This is actually maybe the best thing that's in here, because we sometimes kind of forget what to do with this. This means I need to distribute the negative, which is, and a lot of times what's helpful to understand is that there's a -1 there. If there's just a negative sitting out in front of a parentheses, there's a 1 there, okay, that we need to multiply by or to distribute. So let's go ahead and look at some questions that we can answer and see how we do. Okay, a few more algebraic type situations. All right, Tiffany, we've got 6 times the difference of 5p cubed minus 6p. How would you go ahead and distribute? Okay. All right, so 6 times what first? Okay, 6 times 5p cubed, right? Okay, what do I get whenever I multiply 6 times 5p cubed? It would be 30p cubed, and that's 3 of my available answers. So after that, what do I do, Blayton? Okay, and what do you get with 6 times -6p? -36p. So let's put it all together, and which one of these is my answer? D. Good. D is my answer. So in case you ever go back to watch the video but don't listen, you at least know what the answer is. Okay. Let's come down to number 2. Let's see. Reagan, looking at this, what would be your first step? Three plus x. Where are we seeing 3 plus x at? Yeah, we're on number 2. Okay, so this is 3x to the 5th minus 5b to the 4th. Can I subtract those from each other? No, why not, class? Because they're not like terms. Okay, so you were right to look there first, right? Because order of operations would tell me to go inside the parentheses and see if I can simplify that. But since I can't, what's next? Do I have any like terms that I can combine at this point? The 3x, there's a couple of different 3x's, but you're wanting to combine the 3x to the 5th and the 3x to the 5th. I can't do that until everything is is addition and subtraction. So long as there's multiplication. Do we see any multiplication that can be done here? Okay. All right. So the first thing is just to look inside the parentheses. We can't combine any like terms there. Right. Now I'm going back out to, we don't have any exponents that need to be run down. So the next thing is multiplication. What is the multiplication that we need to do? Keeping in mind that this whole lesson is about the distributive property. Okay, so 5 times 3x to the fifth. I'm going to go ahead and bring that first 3x to the fifth out. What's 5 times 3x to the fifth? What you were about to say? 15 what? 15x to the fifth. And the reason I do that is because, do you remember day one whenever I said no blurts? If I'm calling on one person to answer a question, I don't need to hear whoever just has it. Okay, I'm trying to find out what Reagan knows and what Reagan can do. Okay, I'm not picking on her, but I also don't need you to pipe up unnecessarily. Okay, Jordan, what do you do from here? All right, guys, I feel like we're forgetting what this lesson is about. What is this lesson about? What are we doing in this lesson? The distributive property. When we distribute, do I just distribute to the one thing at the beginning? No. All right, so far, Reagan has distributed to the first thing. What might be the next step? Tiffany? Distribute to the second thing, right? Jordan, what needs to be get distributed? Okay, what does that look like? Tell me what to do here. Do you know? Okay, so let's start off with something like this. Can we distribute this? Tell me how to distribute it, Jordan. 3 times x is 3x. Now what? Is? Okay, so you know how to distribute, right? Okay? That's not any different than what we're doing up here. Okay? She took 5 times 3x to the fifth and got 15x to the fifth, right? What are you doing? 5 times what? 5 times negative 5. What is 5 times negative 5? Negative 25. Okay. Keep going. What's left? It's not just negative 25. B to the fourth. Okay. All right. Now, everything is under addition and subtraction. Now, can I combine like terms? Yes, but I couldn't until then, right? Okay. Christian, tell me about my like terms. Okay, what does that give you? $18x to the what? I just didn't hear you. It sounded like you said F. To the 10th? No. We only add exponents of bases when we're multiplying those bases. All right? So because we're not doing that, right? It's just x to the fifth. Okay? It's like saying 3 carats plus 15 carats, right? We just have 18 carats. All right, there's no change there. So we should get 18x to the fifth minus 25b to the fourth. Okay? Oh, I'm sorry. Right there. Okay. I feel like we're maybe making this way harder than it needs to be. Okay? It's just distribution. Don't make it more complicated. Don't try to do something other than what's there. All right, so let's get some more practice. Okay? April is simplifying the expression 15x plus 5 times the sum of 3 plus x. The table shows her work. All right. In the first place, we see our first step here. She just copied down the question, right? Okay. In what did she do in this next step? Does anybody know? In step 1, she multiplied 5 times 3. Right, this should be a 5x, right? Yep. All right, and in fact, let's see, I'm going to look at my answer key on this because there's kind of a, yeah, so where was her first mistake at? Step 1, right? Step 1 was her first mistake. She didn't, and this is going to be a thing that a lot of people do. We think that we understand the distributive property, but we don't distribute. We distribute to the first thing, but we won't distribute to the second thing. Your mistakes in the distribution property are going to be exactly what she did. Right? Multiply by the first thing and then just bring the second thing down. Can't do it. Okay? So learn from April's mistakes. All right. Let's look at number 4. Number 4 is a good question. Okay? It's a good word problem. A moving van rental company uses the polynomial 84 plus 0.45 times m minus 240 to calculate the rental charges if a customer drives a van more than 240 miles in one day. Okay. In the polynomial, m is the number of miles that the customer drove the van during the day. We want to use the distributive property to write an equivalent expression for the total cost of renting a van and driving it more than 240. Basically, all they're saying here, and it's really, really wordy, is they're saying simplify this expression just like what we've done. Okay? Let's see, McEwen, what would you do first? We're on number 4. Yep. We're basically, all we're doing is taking this equation right here and simplifying it. Okay, so I'm going to bring down 84. All right, you said distribute the 0.45 to m. What does that give me? Good. Okay, now what? Okay. All right, or negative 240. So we want 0.45 times negative 240. $108. Close. We might be missing something. Negative 108. Okay, at this point, what's my final step, Caden? Rearrange them. We could do that. But ultimately, so let's see, you want 0.45 m plus 84 minus 108. Does that help you? Okay, now what? Okay, so you're going to use the commutative property there. All right, now we want the associative property. Okay. Negative what? Negative 24. All right, so we should get 0.45 m minus 24. Right? Simply put, what Caden did was combined like terms. All right, 84 and negative 108. Questions up to this point? Okay, are we getting the distributed property down a little bit better? All right. I do see where we're still struggling maybe with variables and exponents in multiplication. So number 5 would be a really good question for us to answer, maybe the last question that we answer before I let you loose. Okay? All right, so we have 3x to the 6th, y, the difference of x to the 5th, y to the 4th, minus 4x to the 4th. Jeremy, what's the first thing we do here? Are you looking inside the parentheses? You're asking if they're like terms. Let me put it this way. The only time that they're like terms if they have the exact same variables with the exact same exponents. Okay? Keep in mind there is a 1 here. Okay, that's fine. Does 1x to the 5th, y to the 4th have the exact same variables with the exact same exponents as negative 4x to the 4th? No. So can I combine those terms? No. So what's my next step? Well, let's be more complete. Let's say 3x to the 6th y times 1x to the 5th y to the 4th. So what's 3 times 1? Okay? Now, as I'm multiplying here, I'm only multiplying variable to variable, right, in terms of changing anything. So what's x to the 6th times x to the 5th? Good. The variable only changed because we were multiplying those terms. Okay? What's y times y to the 4th? Y to the 5th. Okay, now I have to go back. What's 3 times negative 4? Three times negative 4. 12. Okay, we'll skip over to somebody else and see how they do. Tiffany, x to the 6th times x to the 4th. X to the 10th. And what about, I got y. Y times just a y. All right, are those like terms? Well, they both have variables, right? They both have x and y, but before you jump on the let's add them together bandwagon, do their variables have this exact same exponents? No. This x has 11 as an exponent. This x has 10 as an exponent. This y has 5. This y has 1. They cannot be combined through addition and subtraction. They're not the same. Do you hear me? Okay. If this was an 11 and that was a 5, then I could say 3 minus 12. Right? I could go ahead and I could get my, what is it, negative 9, x to the 11th, y to the 5th. But that's it, right? They would have to be the exact same variables with the exact same exponents. All right. Do we feel like we're in good shape? We can get started? All right. Let me hit stop on this and you guys can begin.